Today we are going to look at absolute value inequalities. So instead of absolute value equations, now we're going to look at what happens when we have less than or greater than with absolute value. So first I would like you to think about this inequality. The absolute value of x is less than 5. For what numbers is that inequality true? 0, 1, 2, 3, 4. All of those numbers, the absolute value of them is less than 5. 1 is less than 5. 4 is less than 5. Because it's absolute value, that would also count negatives. So negative 1, the absolute value of negative 1 is positive 1, which is still less than 5. What about negative 7? The absolute value of negative 7 is 7, and 7 is bigger than 5. So we're talking about the numbers between negative 5 and 5. And there are there's 3 ways to illustrate that. We can say in words the numbers between negative 5 and 5. We could write this as an inequality. Negative 5 is less than x is less than 5. Or we could show it on a number line. Negative 5 to 5, any of the numbers in between negative 5 and 5. This is going to lead us into how to solve absolute value inequalities. If it is an absolute value is less than, I'm going to highlight that. If it's the absolute value is less than a number, we are going to rewrite the inequality as negative number is less than the stuff in the absolute value bars is less than a. So let's just do an example. Number 1, the absolute value of 2x plus 7 is less than 11. If it's a less than inequality, we set it up negative 11 less than 2x plus 7 less than 11. If you want to think of this in terms of distance, the distance has to be less than 11. So from 0 out to 11, all of the stuff in that middle area. To solve this, do you guys remember how to solve a 3-part AND inequality? Right. You want to get the x in the middle by itself. Whatever you do in the middle to get x by itself, you have to also do on the left side and the right side. So the first thing we need to do is subtract 7. So subtract 7 in the middle, on the left, and on the right. That will give us negative 18 is less than 2x is less than 4. Next step, to get x by itself, divide the center by 2, which means you have to divide the left and the right by 2. We get negative 9 is less than x is less than 2. Any number in this range will work in this inequality. Negative 8 would work, negative 7, negative 6, and so on. 0, 1, 1.9 repeated would work. 2 doesn't work because it's just less than 2. We are going to have to graph these, so if you have a little bit of space at the bottom. Just a reminder how to graph these 3-part AND inequalities. Because they're plain less than symbols, we use open circles and we shade in between. The absolute value of 5 minus x is less than or equal to 6. Anytime we have absolute value is less than, we first set it up negative 6 less than or equal to 5 minus x less than or equal to 6. The reason I used less than or equal to is because that's what the original problem had instead of plain less than. Your next step is then to solve that inequality. So we would start by subtracting 5, center, left, and right. That gives me negative 11 is less than or equal to negative x is less than or equal to 1. How do I get rid of the negative in front of the x? And what happens with an inequality when you divide by a negative 1? So 11 is greater than or equal to x is greater than or equal to -1. Now that statement makes my stomach hurt because it's not written correctly. You always want it to be the smaller number is less than x is less than the bigger number. That's just how and inequalities are supposed to be written. So I'm going to rewrite this with the -1 on the left and the 11 on the right. Notice between the -1 and the x, the symbol is eating the x, so make sure your symbol is eating the x. Between the x and the 11, the sign is eating the 11.
So pretty much the same sign.
But the numbers switch. Okay, practice graphing this. This solution means we can pick -1, we can pick 11, and we can pick any number in between those. Hey, let me draw. So what if you have the absolute value is less than a negative number? What is that? It's not possible. The absolute value results in positive numbers. So the absolute value of anything is positive. Can a positive number ever be less than a negative number? No. So it is not possible, which means anytime you have the absolute value is less than a negative, the answer is always going to be no solution. Now on the previous page you might have noticed that the person who wrote this notes packet called the last one the greater than and, or the less than and effect. This one she's calling the great or than effect. So she's changing greater to great or because greater than results in an or inequality. So think about the inequality. The absolute value of x is greater than 5. For what numbers would this be true? It'd be true for 6, 7, 8. It would also be true for -6, -7, -8. So if we wanted to look at this on a number line, it'd be the numbers bigger than 5 and the numbers smaller than -5. This is called an or inequality. X can be less than -5 or x can be greater than 5. So if you have an absolute value, oh my gosh, change please. If you have the absolute value of x is greater than a, you set up the equations, and this actually isn't completely accurate, so I'm going to draw this in extra. X is less than -a or x is greater than a. So the stuff from the absolute value bars has to be less than the negative and then greater than the positive. One of these is exactly the same as the original. The other one you change the sign and change it negative. So let's set up example 3. The absolute value of 3x minus 2 is greater than or equal to 4. The first inequality is 3x minus 2 is less than or equal to -4. Change the sign, change the number. The other inequality is 3x minus 2 is greater than or equal to 4. Notice your second inequality is exactly like your original without the absolute value bars. The first one, we change the sign to less than and we change the number to -4. Less than the negative, greater than the positive. Okay? We have to solve both of these. Or does not mean pick one. We have to solve both. So we add 2 to both sides. Divide both sides by 3. Same thing on the other one. Put the word or in between your two solutions. X is less than or equal to negative 2/3, or X is greater than or equal to 2. I'm going to graph this one up here because I don't have a whole lot of room. Here's negative 2/3, and here's 2. These would both be closed circles. X is less than or equal to negative 2/3, or X is greater than or equal to 2. You would set this up. Negative 3x plus 10 is less than negative 2. On the first inequality, you change the sign and change the number. On the second inequality, negative 3x plus 10 is greater than 2. You just take the absolute value bars out. You don't change anything else. To solve this, let me use a different color. We would have negative 3x is less than negative 12. When we divide by negative 3, we have to switch the sign, so it becomes x is greater than 4. On the other one, when we divide by the negative 3, we switch the sign. Positive 8/3, which is like 2.67. Put the word or in between your solutions and then graph them. 8/3 is actually on the left and 4 is on the right. Open circles for both of them. It says x is greater than 4, so we shade to the right of 4. And x is less than 8/3, so we shade to the left from 8/3. What if we have absolute value of x is greater than a negative number? Think about absolute value always results in positive numbers. When are positive numbers bigger than negative numbers? Always. So, if its absolute value is greater than a negative, the answer is always all real numbers. No matter what you put in here, negative 214, the absolute value of negative 214 is positive 214, which is larger than negative 5. So you can write all real numbers. Do you know the shorthand for all real numbers? If you write the word all and then a capital R with a double stem, it's kind of like the new paragraph symbol in English, but a capital R with a double stem means real numbers. So if you write all and then that symbol, you have basically said all real numbers. Anytime with absolute value, anytime you have a negative number on the right side, you need to stop and think about it. If it's an absolute value equation, you have to stop and think about it. If it's an absolute value inequality, you need to stop and think about it. So number 5, the absolute value is greater than a negative number. Absolute value results in positive numbers. Positive numbers are always bigger than negative numbers. So this one is all real numbers. You don't have to do anything else. No matter how you solve this, every single number that x could be is a solution. The next one, absolute value is less than a negative. Is it possible for a positive number to be less than a negative number? No. So this is no solutions. So the moral of the story here is if you have a negative number on the right side, stop. Don't set it up like a robot. Stop. Think about it because it's probably going to be not a whole lot of work. You just have to think about which of the answers it is.